All right, so now we are on to how do we write and solve and graph a double inequality based off of a word problem. So you have a little bit of a different indication in the words in this type of a word problem, so that will tell you that you're working with one inequality that is set in between two values. So again, it all comes down to pulling out that important information. So we know that at a wind speed of 20 miles per hour, so I'm going to highlight that. I don't know if I'm going to need it yet, but that is a numerical piece of data, so I'm going to grab this. The wind chill temperature W, okay, so we see a variable, we want to grab it. So we know W stands for the wind chill temperature. It's 22 degrees less than the air temperature, okay, so we want to be careful. I see less than, but I want to make sure if this is the less than I want, because we also know that less than can indicate a subtraction. So it's 22 degrees less than the air temperature, which is in degrees Fahrenheit, which is represented by the variable A. So we know that A represents the actual air temperature and then multiplied by a factor. Okay, so this is actually giving me an operation multiplied by 1.3, by a factor of 1.3. So our job is to write, solve, and graph the compound inequality to determine the possible air temperatures. So we are looking for air temperatures. So that's what we're searching for. That's our job. If the wind chill temperature ranges from negative 9 degrees to Fahrenheit to negative 2.5 degrees Fahrenheit at a wind speed of 20 miles per hour. So there's a lot of information in this problem, and we actually don't really need to be using all of it. So it's a matter of really understanding what's important here. So I'm going to start by talking about these variables. So we have to talk about what they represent. So I know that W represents the wind chill temperature. So it's important to grab that. I also know that A, the variable A, represents the actual air temperature. So air temperature in degrees Fahrenheit represented by the variable A. Air temp. So the actual air temperature. And there's a difference because wind chill is that it feels colder than what the actual temperature is. So we want to start with that. Now, what are we looking for? We're looking for the possible air temperatures. So we're talking about the relationship between wind chill and air temp, but our job is to find the air temperature. So what that tells me is that ultimately this is what I'm looking for. This is my job. So that means at some point they're going to tell me what the wind chill temperature is going to be. Now they also give me the relationship between wind chill and air temperature. So they tell me that wind chill is 22 degrees less than the air temperature multiplied by 1.3. So that less than here does not tell me about an inequality. It's telling me about an operation. That less than is a subtraction. So I'm subtracting 22. So here we start having things starting to come together for us. So I know that the wind chill W equals the air temperature multiplied by 1.3. So 1.3A 20 subtracted minus 22. So that's my wind chill temperature relationship to air temperature. So, okay, I'm good there, but that's an equation, not an inequality. What's going on here? What about the 20? The 20 is just telling us that this is the state that it needs to be in before this formula is going to work, and that formula could change depending on what the wind speed is. So we actually don't need the 20. 20 is extraneous data, not necessary to solving this problem. What we do need is the fact that we know that the temperature is ranging, so that's giving us that idea of this is being between two values. The wind chill is between negative 9, ranges from negative 9 to negative 2.5. So now I know how to turn this equation into an inequality. So on one end, I have negative 9 degrees. On the other end, I have negative 2.5, and I know that I can do my double inequality by writing 2 less than or equal to, or less than sign. So this would be less than or equal to because it's ranging from these two temperatures, implying that negative 9 and negative 2.5 degrees are acceptable temperatures. So when I actually set this up as an inequality, I have -9 on one side is less than or equal to, so what I want to deal with, because I've replaced the w, I still need to find the value of a. What is a when it's in between these two values? So I'm going to put in my relationship. What do I need to do to the air temperature to get wind chill? 1.3a minus 22 is less than or equal to my high end temperature, which is -2.5. So again, we are looking for the values of a that is going to keep us between -9 degrees Fahrenheit and -2.5 degrees Fahrenheit. So degrees of actual air temperature when the wind chill is between -9 and -2.5 degrees when the wind speed's 20 miles per hour, indicating that that's the time, that's the conditions for using this relationship here. So now we can solve this all in one go. We don't need to split it up because I can just add perform my properties of equality across all three parts. So I'm adding 22 to each element of my inequality. Oh, I didn't want to cross that out. -9 plus 22 is actually something I need here. So that gives me 13 less than or equal to, now I have 1.3a isolated alone, and then -2.5 plus 22 is 19.5. Last step here is dividing by 1.3 so I can get the value of my variable. So divide every element by 1.3. I now have a 1.3, 13 divided by 1.3 is 10, less than or equal to a, less than or equal to 19.5 divided by 1.3 is 15. So now I have my inequality and I'm ready to graph it. So once again, I want to just make sure I have my number line. And again, if you're not graphing on top of someone else's number line, you're good to do this however you want. I typically just do, again, those two numbers, my two target numbers, and then, keeping really messy with these, it's between 10 and 15 degrees. These are inclusive, so these are closed circles on 10 and 15, and then we're connecting our two values because that indicates that our temperature needs to be between 10 degrees Fahrenheit to 15 degrees Fahrenheit in order for our wind speeds, or in order for our wind chill to be -9 to -2.5 at that 20 mile per hour wind speed. And that is us solving this double inequality from a word problem by modeling, solving, and graphing.